this is actually my second time recording this because my audio got cut off halfway. But anyway, uh, today I hope that uh, today's video will be helpful for you guys because I was just made aware that chemistry practical for O level is just 2 days away as of the time that I'm recording this right now, and I got a request on Reddit on going through planning question, and yeah, let's get to it. So for planning question, um, I'm aware that a lot of people consider it the hardest part of planning, and even at the A level, whereby planning can go up to 10 marks. Yeah, I understand why it can be hard because there are a lot of things that you guys can consider. The first obstacle is even considering of the right experiment to do. But I'm here today to tell you that planning is actually the easiest. Yeah, it's actually the easiest. Oh my goodness. Okay, so going back, sorry. I'm here to tell you that it's actually the easiest part of practical. And why do I say so is that actually in your practical, I'm just changing the highlight to lighter a bit. Okay, so if you think about it, in your practical paper, you have to do the actual experiment, right? And there's a risk of you messing up your experiment. Let's be real lah, huh? Let's be real. Like such as overshooting your endpoint for titration. You don't see any precipitate for your QA, and you crack a boiling tube, you drop something, or you forget to filter something, or your eyes that day went crazy. Yeah, there's a lot of very things that you can mess up considering how nervous you can get unless you are a genius lah. So but for planning, you simply just have to sit there, think and think and think and think harder a bit, and then you write down and get the full 5 marks. And hence, personally for my A level, I actually started my practical paper with the planning question first before I move on to doing my experiment. And today I don't really have time to cover the entire practical syllabus, yeah, for the O level people. So I'll be targeting on planning instead. So, uh, and to be frank, the last time, the time that, sorry, the time that I did O level, in Sec 4 was quite some time ago, and I'm not used to it, because so I do my best to explain myself to you guys, but I believe that the thinking behind it is the same. Yeah, and I hope that you guys will benefit a lot from this and get that full mark for your planning. Okay, so first, how do you guys approach planning? So the first step is to identify the relevant chem concepts, such as oxidation, electrolysis, acid base, decomposition. When you guys read the question, all this should pop up to you guys very quickly. Yeah, I will be going through 2 sample questions and you guys will see what I mean. So the second step is consider what are the possible chemical reaction. For example, you guys see a metal, right? What can a metal react with? Acid? Yeah, also possible. Metal plus acid reaction. And then what if you guys see like carbonate? You guys can react with acid as well, right? How about you guys see hydroxide? It's a base, can react with acid as well. How about you guys see acid itself? You guys can react with base, right? Yes. So all this should come to you guys very quickly. How about halides or displacement reaction? So all this should come to you guys very quickly, and in all honesty, it takes a lot of practice. Yeah. So I hope that within your next 2 days of revision, you guys will aim to do what I've said. And if you're watching this later in next year in 2024, please start doing this as early as possible because it really helps a lot. Okay, so next for is the procedure format. So after my years of doing chemistry, not years, but decently long enough, I I noticed that there's actually a format to how you explain your procedure. So in every step that you use, right, there should be an apparatus followed by an action. For example, using a tensium cube measuring cylinder, that's the apparatus. The action is measure out 5.0 cm cube of FA1. That's the action, right? And in fact, That's this is really all there is to planning. It's just apparatus action, apparatus action, apparatus action, apparatus action. So every apparatus should be follow, accompanied by an action. You can't simply just grab an apparatus like a measuring cylinder and no action. So you guys just hold it. Does it make sense? And you guys can't just do an action without an apparatus. Like weigh out 1 gram of solid. So you guys weigh out by hand. Or there should be an apparatus, right? Which is the measuring scale, the weighing electronic weighing scale. So every apparatus should follow by an action. And in fact I believe that this may be the most important point for today. And if you guys don't take away anything, just take away this format so that at least you guys don't mess up your planning. At least get some marks from it. Okay, fourth is use common lab apparatus. Because someone asked me that someone told me that they they don't know how to decide which apparatus to use. Just use whatever is given to you. Just you don't know during exam. Just look around you. Look at your lab. We do not look at don't look at other people. Like again, I don't want to say anything about that, but look at what is provided to you on your bench. Are you provided with burette? So it means burette can be used. Are you provided with conical flask? You can use a conical flask. So use a common lab apparatus. Okay, I'll be going through 2 sample questions to show you guys my thinking process. Okay, so let's start off. So I found these 2 questions online. Thank you, grail.moe. Okay, so first, let me switch to red. Using X is zinc powder. So I like to write the symbol on top. Contaminated with carbon. So if it's contaminated with carbon means this is an impurity. Plan experiment to purify X and determine percentage purity. Okay, so this is a concept. So you are trying to find the percentage purity here. So what are the possible chemical reaction and concept that you can think of? Like I mentioned just now, one very obvious one should be acid reaction. Next one can is solubility, right? And in fact, I strongly believe that these two are the major one. Yeah, at least at the O level. Yeah. Meanwhile, A level there are other things. Okay, I'm not going into that. Yeah, so uh, I'm not saying that these are the only two. There are many other things that I consider, such as oxidation. Okay, so I tend to write my ION as N. Yeah, so just for clarification. Electrolysis. Yeah. So all these concept right here should pop up to you guys fairly quickly with enough practice. Okay, you're gonna continue. You can assume all okay normal. No any assumption include measurement. Okay, all these are normal. Okay, so now let's get started. The now let's get started with the answer. So you guys can pause the video, think about how you have to approach this. So when I first read this question, something that can come to my mind very quickly is that this carbon here is a solid, right? It's a solid. So let me just note it right on the state symbol as because it's a powder, in a powder form. So I'm aware that this carbon won't react with any acid, but this zinc can. So I know that I can use some certain acid react with zinc so that the zinc dissolve and then I filter out the carbon. So you guys can think of this in your head. Yeah. So now let's get to the answer. Okay, so I here we go with the apparatus and action, the third step. Insert an electronic balance. This is apparatus. Measure. This is action. A fixed mass. Okay, here is very important. Note down any quantity you use or volume. Why do I say so? Look at this. Include the measurement you would take, right? Okay, using an electronic balance transfer. Oh, okay, this is extra. I'm sorry. Can Ignore this. Measure and transfer to a beaker. Okay, so let's go to the next step. So now the solid is in the powder is in the beaker. So add the next step is to add. So here's your action. 2x. Okay, ignore this. 2x in a beaker and swirl the beaker or stir with a glass rod. I personally prefer stirring with a glass rod, but really up to you guys. So you can see it here again. Here you get your action, and here you get apparatus. Until no more effervescent scenes. Yeah, and to ensure complete reaction with zinc between the acid and zinc. So once uh once the bubbling is stopped, once the bubbling stops, you guys know that the reaction with all the zinc is completed, and all that's left behind is carbon. So the carbon left behind. Okay, let's move on. Filter the mixture through a filter paper to obtain unrated solid carbon as residue. So here's your action again. Filter, filter paper, apparatus. You guys can even be apparatus. I forgot how to spell. Even in a filter funnel. Sure, you guys want to add that in to obtain unrated solid carbon as residue. Then moving on. Wash the residue with distilled water and dry between sheets of filter paper. So wash, you do action again, distilled water, apparatus, or reagent, sure. Dry is your action, is apparatus, filter paper. So you can see that in literally every single step, there's an action, there's an apparatus, there's an action, there's an apparatus. They always go in pair. There's an action, there's an apparatus, there's an action, there's an apparatus, action, apparatus. So that's really all it is to planning. So the hardest part here, the hardest part here is to even identify these correct experiment procedures to carry out. So once you guys figure out that procedures, all you guys have to do is write correctly using this format that I've identified. So using a weighing scale, using C is the same. It's really all the same. Weighing scale apparatus, action. Okay, it's right. Let's just use ACAP. Measure the mass. Blah, blah. Okay, and then record it as Y. Here's your data recording, which is another important component of planning, data recording. And I just want to highlight to you guys that feel free to use variables, okay? Feel free to use variables. So feel free to use variables for your data recordings. So for example, uh, start timer and record time taken as T. And if you guys are recording multiple experiments, you guys can record it as T1, T2, T3, T4, T5. When you guys measure mass, you guys can use XYZ or X1, X2, X3, X4. Yeah, so use all these variables so it helps you guys to demonstrate the sorry, use all these variables to illustrate your experiments and illustrate how you're gonna carry this out. And I know that this sounds very confusing, especially if you guys are not used to using all these variables. But trust me that this will really make it clearer to the marker and whoever's reading it. So my mass of zinc in X is 2.0 minus Y. So this Y here is actually your carbon mass. You just move this box away. So here's how you get the final answer. The percentage purity is this times 100. So here's a mass of zinc mass, and this is a total mass. And you multiply 100 to get a percentage. Yeah, so this last step is to answer the question how you would use your result to determine percentage purity of X. Yeah, so that's really all there is to planning. And I try to download this PDF and share with you guys so you guys can refer to, yeah, and share with your friends if you guys need to. And this is only the first question. I'll be going through one more question, but please feel free to stop the video here and go and do your own practice. Yeah. Okay, so moving on to the next question. Honestly, I'm kind of tired. Yeah, it's taking longer than expected. So agricultural limes, a mixture of calcium carbonate and calcium oxide. So I notate it down. Oh, that's really thick. So CaCO3, CaO, farmers use. Oh, I don't need that ad, man. What is this? Ah, okay, whatever. To neutralize acidic CD. Oh, I can close it. Right. So neutralize acidic CD. Okay, here they already give you the concept. React with acid. Right? So plan investigation to find out which two different QR will neutralize more acid. So this is the aim of the experiment. So this question is kinder in the sense that they tell you straight up what is the concept involved. So it's acid reaction. So you have for carbonate you have metal carbonate. In this you guys have base plus acid. Right. Okay. So for this question I just want to highlight that they simply just say find out. Wait, let me use a different ink. They just say find out which neutralize more acid. So they just ask to find out Q is more than R or R more than Q, right? They never ask you to determine specifically, not specifically. They never ask you specifically determine how much Q react or how much R react. So you guys don't actually have to do like make it too complicated for you guys. So I explain more about that later. So let me just continue writing it here. Specifically, how much each line react. So when you guys determine something specifically is quantitative, and Q more than R more than Q is qualitative lah. So let's go straight to the answer. So use an electronic balance. Uh, okay, so from now on, my apparatus I write AP, way action I write C. This is your measurement. This is your action. This is your apparatus. Yeah, that's what they use. Okay, so add action to his apparatus. Okay, so I should highlight something here that you can note down the volume of the pipette here because I know that some teachers are maybe quite particular about this, but based on what I've seen from O-level Ansaki, majority of them don't even include the volume, yeah, of the pipette measuring cylinder or whatever apparatus you're using, and label this F81. Okay, so this is what I mean by use your variables. I spelled it wrongly, but it doesn't matter. So use your variable if you guys have to. Okay, so moving on. Add 2, 3 drop guitar indicator. Okay, add 2, 3 drops of guitar indicator. Orange indicator. Fill indicate fill AC apparatus is your action to add. Okay, here to be honest, there's 3 new apparatus here because it comes in the bottle. So pardon me for that. With dilute your bench reagent. Oh, sorry. Titrate. titrate action against the apparatus until the color change from red to orange. So this is how you know where to stop. Repeat if R labeling lime R as Fa2, so it's your another variable. Conclusion, the lime which requires smaller volume of sodium hydroxide, neutralize more acid. So just want to go through a bit of the concept here and what exactly is going on. So uh, so let's say a lime, right? Lime, when you're adding lime plus a fixed volume of acid, fixed volume of acid, the lime that reacts more, we have less acid unreacted. So when there's less acid unreacted, you need less smaller volume of NaOH needed. Okay, so I just want to brush through this experiment quickly, yeah, because most of the points have been mentioned in the previous question, and I hope that this has been useful to you guys about how you guys approach. Yeah, so really the hardest part is to identify the correct experiment to use. Yeah, and really just follow the format of apparatus and action, and you guys um what they choose to do are more than safe to go. So really all the best for your practical planning. Yeah.